So let's just go through the answers for the critical angle activity. So the first one is slowly increasing the angle of incidence. You should see the reflected ray become stronger as you increase the angle of incidence, and that the critical angle that you calculated, so this particular example, the critical angle was 41 degrees, and then you can calculate the refractive index because you have n equals 1 over sine c. So if you rearrange that equation for 41.1 degrees, you end up with a refractive index for glass of 1.51. Okay, so question 45. Given the refractive index of a certain medium, calculate the critical angles. Okay, so those are the critical angles. For air and water, it's 48.6. For air and glass, it's 1.52. So it'd be 41.1. For air and glass, this particular kind of glass called crown glass, the refractive index is changed to 1.92 and the critical angle becomes 31.4 degrees. Air and diamond, 2.42 for the refractive index of diamond, and therefore the critical angle is 24.4. And water glass, now we're given two refractive indexes. Okay, so I'm going to go through the details of the answer shortly, but the answer is 61 degrees. And for water and diamond, where water has a refractive index of 1.33 and diamond 2.42, the answer is 33.54 degrees. Now the question is, how did I get to that? Well, when you think about it, let's look at the example of air and water. Okay, so basically what you have is the medium of air and the medium of water. Okay, and air has a refractive index of 1. And the water has a refractive index relative to air of 1.33. Okay, so the refractive index just becomes a ratio of the refractive index of water over the refractive index of air. Okay, so that'll be 1.3 over 1, which gives you the refractive index of 1.33. Okay, so for this question here, we no longer have air, we have water as the medium. So the medium is going to be water, the refractive index of 1.33, and glass, which is 1.52. Okay, so now the refractive index is going to be equal to 1.52 divided by 1.33. Okay, and that means we end up with n being equal to 1.14. We find the critical angle, or sine c at least. Okay, so sine c will equal 0.88. That's terribly drawn. I'm no good at drawing 8s quite clearly. 8. Okay, which means that the critical angle is going to be the sine -1 of 0.88. Okay, so the inverse sine of 0.88, which will equal 61 degrees. Okay, so that's for that one, the water to glass. And conversely, if instead of water to glass, so I'll just rub that part out there. Okay, so the other example, you now have water and diamond, so you've got water here and diamond here. So the refractive index of water is 1.33, diamond is 2.42, so the refractive index of the entire system will be 2.42 divided by 1.33, okay, and that equals 1.82. Okay, so you find sine c, okay, because we remember we're using the equation the refractive index equals 1 over sine c. Okay, so you find sine c, which should be 0.55. Okay, and then you take the inverse sine again, so the inverse sine of 0.55 will give you the answer of 33 degrees. And that's how you find that out. Okay, so the last question, last question, 46, describe the changes in intensity. Okay, so what we're doing basically is you have your angle there, you have your normal line going through, you have an angle of incidence, okay, you have an angle of reflection, and an angle of, arrow's going the wrong way, an angle of refraction this way. And what the question is asking is describe a change in intensity. Okay, so the reflected ray starts weak and becomes strong, and the refracted ray starts off strong. You should have seen it become weaker until the point where it completely disappears. And that is the answer for the last question, question 46.